The evening of April 23, 2026 started like any other Thursday in Enid, Oklahoma. The Storm Prediction Center had issued its morning outlook. The probability of a tornado forming over the city, 2%. Not zero, but close enough that most residents had no reason to check the sky. Then, at 8:11 p.m. Central Time, southwest of Vance Air Force Base, the ground began to change. A vortex dropped out of the darkness, silent at first, tightening as it crossed the base's runway. Within 60 seconds, it had already snapped utility poles and torn bark from trees. By 8:20 p.m., it was moving through a neighborhood filled with homes, families, and the kind of ordinary Thursday night life that never gets to stay ordinary once a tornado finds it. And what happened over the next 37 minutes would not only reshape a community, it would ignite a debate inside the meteorological world that is still unresolved today. The official rating reads EF4, with peak winds of 180 miles per hour. But on July 29th, 2026, researchers from the University of Illinois Urbana-Champaign and OAA's National Severe Storms Laboratory published wind calculations that told a different story. Their number, exceeding 205 miles per hour, with estimates reaching between 210 and 220 miles per hour. That sits squarely in EF5 territory. The question they raised, and the one this video will work through, is whether the Enid tornado was quietly one of the most powerful storms to touch down in modern American history, and whether the official rating actually captured what happened on the ground. If that question matters to you, stay here. The evidence runs deeper than you might expect. Garfield County, in northern Oklahoma, is no stranger to severe weather. Tornado Alley cuts straight through this part of the country, and the open plains that surround Enid offer no natural barriers, no mountains, no terrain to break a storm apart. What meteorologists call favorable shear, meaning the wind conditions that allow air columns to spin, is available across this region for weeks each spring. But April 23rd did not look like a dangerous day. A sharp dryline boundary was interacting with an emerging upper-level trough across northern Oklahoma. When the Storm Prediction Center released its morning convective outlook, the Enid area carried a much higher tornado probability within an enhanced risk category. Forecasters were watching southeastern Kansas and central Missouri, not Enid. The atmosphere, as it turned out, was not watching the same models. Ahead of a slow-moving upper-level trough, a small but unusually concentrated area of wind shear had developed in the low levels over Garfield County, creating the conditions for a brief but violent spin-up. Radar showed a supercell thunderstorm developing southwest of the city, and the rotation signature tightened quickly, almost too quickly for the warning infrastructure to keep pace with. A tornado warning was issued, but the storm was already on the ground. At 8:11 p.m., the tornado formed southwest of Vance Air Force Base. At this point, the vortex was still in its early stage, crossing open fields with relatively minor damage. Trees fell. Debris scattered. A few structures on the base property showed minor disturbance. The base would later close temporarily as crews assessed the grounds, but the physical damage there remained modest, mostly confined to the runway corridor. The real story was building just across the street, in the residential neighborhoods to the east. As the tornado crossed US Highway 81 into the Gray Ridge residential area at 8:20 p.m., its character changed. 9 minutes after touching down, the vortex had widened to a maximum of 600 yards across its damage path, and the destruction escalating across that width was no longer minor. Homes suffered severe structural damage, with many partially leveled. Rooftops did not just lift, they vanished entirely. Trees did not just fall. The bark was scraped from their trunks, the wood beneath polished smooth by high-velocity debris. This last detail, the debarked trees, would become one of the most talked about pieces of physical evidence in the damage surveys that followed. Rayanne Hunt was inside her home in Gray Ridge when the warning hit her phone. She stepped outside for one look. What she saw coming toward her was not a distant funnel cloud, not the kind of object you photograph from a porch. She scrambled back inside, grabbed her husband, her brother-in-law, and a neighbor, and they dropped into her concrete cellar, an 8-by-8-foot room beneath the house. In the darkness, she could hear metal slapping against the cellar door, glass breaking overhead. In the darkness, she could hear roaring, metal slapping against the cellar door, and glass breaking. When they emerged, the home remained standing, though its windows were smashed and its roof was heavily damaged. She and everyone with her walked out without a scratch. That outcome, 4 people surviving the direct path of what the survey teams would rate EF4 inside a small concrete room while surrounding structures were stripped to their foundations, became one of the defining human images of the entire event. If this is the kind of story that deserves more attention, subscribe to this channel. There are more events like this one, where the numbers and the human detail together tell a story that neither one can tell alone. Around the same time Rayanne Hunt was climbing out of her cellar, a news crew was pulling into the Gray Ridge neighborhood. TV reporter Rob Hagan had recently joined the local news station after moving from California. When he stepped out of the vehicle and saw what was in front of him, He became audibly emotional. His voice broke as he described block after block of flattened ground. He was not describing the scene. He was absorbing it. The footage of that moment circulated widely because it captured something that damage statistics cannot. The visual scale of what an EF4 at 600 yards wide does to a subdivision. At least 40 homes were damaged or destroyed. But those numbers, on their own, do not convey what the neighborhood looked like. Slabs of concrete sat empty where walls had stood for decades. Trees stood stripped of their bark and limbs, while power lines were wrapped with debris. Large piles of twisted metal, splintered wood beams, and insulation gathered at the edges of building foundations. Dave Lamberton arrived the morning after to find his son Joseph's woodworking shop flattened. Tools, lumber, machines, years of work reduced to a pile of broken wood and twisted metal. He spent Friday morning digging through it, not because much could be saved, but because it was something to do, some way to make contact with what had been there. His son's work was gone. The storm left 10 people injured, though authorities reported only minor injuries. 0 fatalities. In a neighborhood that bore this level of destruction, that number sits close to impossible. Researchers and emergency management personnel noted the strong tornado shelter culture in Oklahoma, the years of public education that had led families to build cellars, know their exits, and respond within seconds when warnings came. Ray and Hunt's cellar was not an accident. It was a decision made long before April 23rd. The tornado's path, meanwhile, was doing something unusual. After plowing through Gray Ridge, the vortex executed a tight looping maneuver southwest of South 30th Street and Roop Road at 8:30 p.m., an abrupt change in direction that left damaged surveyors mapping a path that bent back on itself. This kind of loop is rare. It happens when the storm's parent circulation shifts faster than the tornado can track, pulling the vortex into a curved arc rather than a straight-line track. The result, on the ground, was overlapping swaths of damage, areas where the wind had hit twice from slightly different angles, creating patterns that made the standard damage rating process more complex. National Weather Service teams from the Norman office arrived the next day to survey the path, documenting each damage indicator: the debarked trees, the concrete slabs scoured clean, the homes stripped to the foundation. They walked the 9.5-mile track from the original touchdown southwest of Vance all the way to where the tornado's rotation collapsed at 8:48 p.m. Their official finding: EF4, with estimated peak winds of 180 miles per hour. In the enhanced Fujita scale, that places the Enid tornado among the most powerful tornadoes to strike the United States in recent years. EF4 winds between 166 and 200 miles per hour are capable of leveling well-built homes, throwing large vehicles considerable distances, and debarking trees. The survey team's rating was consistent with what they observed. Their methodology followed standard NWS protocol: find the highest damage indicator, match it to the degree of damage tables in the EF scale, and assign a wind estimate accordingly. But the physical evidence on the ground had already raised a question that protocol could not fully answer. On May 19, 2026, NOAA's National Severe Storms Laboratory and the Cooperative Institute for Weather Research and Operations published findings from survey teams that had examined the Enid path equipped with LiDAR technology, a laser-based scanning system that creates detailed three-dimensional maps of terrain and surface features. The goal was to document unique damage indicators not currently captured by the standard scale, such as the lofting of heavy objects and spatial variations across the damage path, where topsoil had been stripped away, where asphalt had been scraped off roadways, and where the debarked trees stood. The LiDAR data would allow researchers to measure the depth and extent of each indicator. What the scans revealed were zones of ground scouring and tree debarking that, in intensity, exceeded what standard EF4 wind estimates would typically produce. Debarking in particular results from extreme wind forces and high-velocity particle bombardment, which can occur in a matter of seconds during a brief impact window. The wood beneath the bark on several trees showed not just surface abrasion, but deep scoring, consistent with extreme debris velocity at very low levels above the ground. This data became the foundation for the July 29th paper. Researchers from the University of Illinois Urbana-Champaign and NOAA NSSL applied near-ground wind speed reconstruction techniques using physical damage indicators and structural impact analysis. Their conclusion: the 3-second peak gust in the worst damage zones reached approximately 205 miles per hour. That figure crosses the EF5 threshold, which begins at 200 miles per hour under the current scale. The response from the meteorological community was immediate and divided. One side of the debate acknowledged the rigor of the UIUC and NSSL methodology. Near-ground wind reconstruction from physical indicators is an accepted technique, and the researchers involved carry strong credentials. The physical damage data supporting the 205 MPF estimate was publicly released, allowing independent review. If the number holds, the Enid tornado would become one of a very small number of storms in recorded history to produce documented EF5 level winds, and the only one to do so in an area that carried a 2% tornado probability that morning. The opposing position pointed to the inherent uncertainty in damage-based wind estimation. The EF scale was designed as a practical tool, not a precise scientific instrument, and the gap between 180 and 205 miles per hour, while meaningful, falls within the range of variability that the scale itself acknowledges. Without a ground-level anemometer or Doppler radar wind measurement taken at the exact damage location, any wind estimate remains an approximation. The National Weather Service, as of July 2026, has not announced a formal review of the EF4 rating. A 15,000-pound recreational vehicle, parked on its owner's property in the path of the storm, was lifted clear of the ground and thrown 920 feet before its metal chassis came down. To move an object of that weight, that distance requires a force that damage engineers have struggled to reconcile with a standard EF4 event. The RV landing site became one of the most closely examined data points in the entire post-storm analysis, because the physics of the throw, when calculated backward to estimate the wind speed required, produced a number consistent with the UIUC findings, not inconsistent with them. At 8:48 p.m., 37 minutes after it first touched down, the Enid tornado dissipated and lifted from the surface. The vortex lifted. The roar that residents described in cellars and closets and interior bathrooms across the south side of the city went quiet. Just like that, the storm was over. The parent supercell continued northeast, but without the low-level wind shear that had fed the tornado, it could not sustain another significant vortex. The silence that followed was what many survivors remembered most. Not the noise of the destruction, but the speed with which the noise stopped. Garfield County issued an emergency declaration on April 24th. Crews had already begun clearing debris from roads even before the official emergency declaration was issued. Utilities worked to restore power to hundreds of homes. The Red Cross set up a shelter at the Chisholm Trail Expo Center for displaced families. Joseph Lamberton's woodworking shop would not be rebuilt quickly, and the Gray Ridge neighborhood that Rob Hagan had cried in front of on live television would take months to clear and longer to rebuild. The debate over the tornado's true wind speed had begun to move through academic channels as well. Research groups studying the EF scale's accuracy, a field of inquiry that had already been active for years before the Enid event, pointed to April 23rd as a case study in the scale's limitations. The current EF scale uses structure and vegetation damage as its primary indicators, but those indicators were developed for more common wind ranges. At the extreme high end, the separation between EF4 and EF5 becomes difficult to resolve from damage alone. If the 205 miles per hour estimated finding survives peer review, Enid will matter not just as a local event, but as a data point that changes how researchers discuss the frequency of EF5 level winds in the central United States. The standard assumption has been that true EF5 tornadoes are extraordinarily rare, occurring perhaps once every several years. An event hidden inside an official EF4 rating in a 5% risk zone would challenge that assumption directly. The Enid tornado of April 23, 2026 covered 9.5 miles in 37 minutes. It destroyed or severely damaged 40 homes. It threw a 15,000-pound vehicle nearly the length of 3 football fields. It stripped bark from trees with a thoroughness that drone imagery and ground surveys are still being used to document. 10 people were hurt. None were killed, a fact that owes itself in no small part to the concrete cellars and ingrained weather awareness of a community that had been preparing for exactly this kind of night for years. Whether the wind that produced all of this peaked at 180 miles per hour or reached even higher intensities is a question meteorologists and engineers continue to discuss. But the physical record on the ground is not in dispute. The debarked trees still stand in Gray Ridge. The scoured concrete slabs are still there. The path is documented in 3 dimensions, preserved in high-resolution drone photogrammetry data at a level of detail that earlier storm surveys never had. What happened in Enid on a low-risk Thursday evening is a case study in how quickly the atmosphere can exceed every forecast, how survival depends on preparation built over years rather than decisions made in seconds, and how the tools used to categorize extreme weather sometimes struggle to keep pace with what extreme weather actually does. The science is not finished. The neighborhood is not rebuilt. And the EF scale debate that this storm accelerated will likely shape how the next generation of researchers rates the storms that come after it. If this story caught your attention, subscribe and like this video. There are more events like this one worth documenting, and every view helps put them in front of the people who should know about them.